Okay, so this learning target's called just solving advanced probability problems. It's really a culminating learning target. Just gives us the opportunity to blend everything together, and so that we basically want to get you ready for the fact that on the test that you're going to have to make the decision whether or not to use permutations or combinations, and you have to understand when to use the best method. So we just want to make sure that we assess you and we just talk about the permutations and combinations together, so that you can that you have practice making that decision. So as a warm-up, I just want to ask the question, and just want to put you in a situation where you try to figure out if we're dealing with permutations, combinations, or technically both. And so the first one is probability dealing with cards in your hand. So probability dealing with a password, probability dealing with the lottery, dealing with a committee, so selecting a committee, dealing with selecting some to all of a pile of books, so not necessarily all, but at least some of the books, and probability dealing with top 5 in a race, and probability dealing with giving out prizes. So if you can just think about it, you can pause it and think about it for yourself, and then I'm just going to walk through the answers. So probability dealing with cards in your hand is combinations. You can argue it's permutations if you're talking about the order that you're getting them, but technically whenever you're dealing with cards, it really doesn't matter what order you get them. You've got the cards in your hand, you can shuffle them in your hand. It's a combination. Probability dealing with a password is a permutation, and so it's with password order matters, and so it really has to be a permutation. Probability dealing with the lottery is usually a combination. Usually the lottery, the order doesn't matter. That's specifically a lottery. If you're talking about prizes for a password, or you get the right number in the right order, that would be a permutation. But general, the lottery, Lotto 649, Lotto Max, those are combinations. Probability dealing with a committee, it all depends. If there are roles, then it's a permutation. If there aren't any roles, it's just a group of people, then it's a combination. Probability dealing with selecting some to all of a pile of books, that's the Pascal's triangle question. So it's saying if there are 10 books and you've got multiple cases where you can select 1 or 2 or 3, that would be the 10th row of Pascal's triangle, 2 to the 10. Probability dealing with top 5 in a race, it's both. It also depends if we're ranking them or we're just taking a top 5. So if it's top 5 advanced, we just want to find out a group of 5, and then either put in alphabetical order or they're put in the order that they signed up, and it doesn't really matter. But if we're taking top 5, first prize, second prize, all the way to 5th, then the permutation would matter. And if we're giving out prizes, that depends if the prizes are the same or they are different. If they're the same, it really doesn't matter who gets what. If they're different, then it matters who wins that grand prize. Probably the 5th if you'd say top 5 again, it's the same idea. And so it matters who gets the grand prize. Learning target, I know when it's appropriate within a probability problem to use permutations, combinations, the fundamental counting principle, and the rule of sum. So remember, the fundamental counting principle just connects things with multiplying. The rule of sum talks about cases. And you can make decisions with respect to the proper strategy to use, and can solve complex problems that require multiple strategies. And so we are going to put you in a situation where you have to use these, and you have to use permutations or combinations. So we just walk through this flowchart. Determine the total number of objects that can be selected. So if we're ever trying to find total ways, that's N of S or N of A. You got to ask yourself, is order important? And if it is, then it's a permutation. And then you ask yourself, are all of the objects being arranged? And if all the objects are being arranged, then it's a factorial. So you go all the way down to 1, all of the objects are being arranged. If it's not, we're probably just arranging a certain amount of objects, and we would call that a permutation NPR. If the order is not important, then it's a combination. So we just asked the question, are you choosing exactly R objects from N? So are you choosing exactly 5 cards from a set of 52? If you are, then it's a combination and choose R. If you're not, then you might be doing that like that books question again, like using 2 to the n to find out the total number of combinations, and subtract 1 if you don't want to include the case where you have no books. Or you might just have to count the individual cases and use the rule of sum. And so you might like have a bunch of combination questions, a bunch of NCRs, and then you got to add them all up. And that's usually what happens. Where you have like a rule of sum situation. There's the clock going off again. If you're dealt 5 cards, what's the probability that your hand contains a straight? So this is a cards example. I just wanted to do 2 quick examples here. So a straight is 5 cards in a row. That could be ace to 5 or 10 to ace. Typically ace to 5 also includes a straight. So we start by doing your N of S. The total number of ways is 52, choose 5. That's usually like a poker hand is 5 cards, although Texas Hold'em has seemed to replace poker, and Texas Hold'em hand does have 5 cards, but really there's 7 and you use top 5 and that kind of thing. But there's really 2 cards that you're dealt. It's a lot more complicated than this. But we just have 52, choose 5. You have 5 cards in your hand. That's 2,598,960 different hands that you have. Case 1 is when you have the ace to 5. And so I just want to like kind of be careful here. And so like if you have an ace, there's actually 4 aces that you can have, and you're going to choose one of them. There's 4 2s that you can have, you're choosing one of them. And there's 4 3s you can have, and you're choosing one of them, all the way up to 5s, and you're choosing one of them. So you have a fundamental counting principle situation here where you've got 4 choose 1 times 4 choose 1 times 4 choose 1 5 times. Case 2 is 2 to 6 is the exact same. Case 3 is the same. Case 4 is the same. Case all the way up to case 10, which is 10 to ace. 10 jack queen king ace, and that's the exact same thing as well. And that's the last straight. There's actually 10 cases here, and they're all the same. And so your N of A is actually 4 to the 5, which is 4 choose 1 times 5. Or 4 choose 1 5 times, sorry. So that's 4 to the 5 times the 10 cases. This 10 represents the cases. And so we get 10,240. And your probability is just 10,240 over 2,598,000. And it's approximately 0.39%. So the odds of being dealt straight, or the probability of being dealt straight is very low. It's less than 0.5%. You'd think it was a little bit higher, like it's not that hard to get a straight. But when you're just dealt 5 cards automatically, usually when you deal with poker, you have like a draw afterwards where you can drop some. That's why Texas Hold'em, there's 7 cards to deal with, so that you can kind of place together straight with the top 5 cards with the 7. Because really, like if you just have 5 cards, it's really hard to get a straight right off the bat. It only happens 1 out of 200 to 300 times. Password example. So a password is 5 letters long. You're told the password starts with the letter A. You can only use each letter once. What is the probability that the password has at least one other vowel? With a password, like we talked about in the warm-up, order matters, so it's a permutation. And so we're saying, what is the probability that the password has at least one other vowel that doesn't include Y? So Y is not a vowel. N of S is going to be like, if you know it starts with 1 or with A, like that is actually one of the probabilities. We go back to the slot method with permutations. It's always good to start with the slot method and then just use the permutations to shortcut it. We don't use slot method for combinations, but in permutations we can use the slot method. There's actually one way for the first letter to be a letter A. We already know it starts with A, so it's got to be 1. 25 ways to pick the second, 24, 23, 22. So a total of 25p4, which gives me a total of 303,600. If it's at least one other vowel, we actually use the indirect method. A prime is the case where we have no other vowels are used. If you try the direct method, it's very challenging to say, okay, well, we can use E, and we can place E in one of these 4 spots, but we can also use O. We can use E and O together. We can use E, I, O, and U. So we got a whole bunch of cases, and so it's just way quicker to use the indirect method. N of A prime, again, we have 5 slots. The first one has to be A, so there's only one way to do the first one. And the second one, so we take out the vowels. So if we remove all 5 vowels from the 26 letters, we only have 21 letters left. There's 21 ways to do the second, 20, 19, and 18. And so in total, you get 21 P4, which is 143,640. N of A is the difference between those two, and the probability of A is N of A divided by N of S, which is about 52.69%. So the probability the password has at least one other vowel is pretty high. So we know that about over half the time you can have at least another vowel in there. Okay. Practice, there's a bunch of questions that are littered throughout the 2 chapters, and they're really your review questions. 15, 8, and 19, I just wanted to challenge you because those were just calculate the number of ways. I want you to think about a question that would require you to calculate probability, and probability where you possibly have more than one case, and that's the rule of sum. Okay, so I just challenge you to think about that because that's potentially what you're going to be asked to do. And so I just want you to be ready for that. Okay? That's it for today's lesson.